This should be a quick one, everybody. Let's go over the homework for sampling with and without replacement. First and foremost, maybe most important for you, this homework as well as the lesson could be worth 38 points. Yes, 38 points. Wait, I thought I said 36 yesterday. Don't forget the homework that you're going to hand in to me. So 18 points for example number 1. 18 points for example number 2. Right here. Plus the 2 points for doing this homework. This can potentially be worth 38 points out of 100 points. Crazy, just from one question, and it's not bad at all. First and foremost, take the population, parts A and B, find the mean and standard deviation of this population, put this data into L1 as stated before. Then to find part A and part B, the mean and standard deviation, do stat, do calc, and then do 1-bar stats. Simple enough for a population. Okay, questions on that? Hopefully not. Now let's go to part C, where we actually take a sampling distribution from the population. Samples of size 2. Now last night's homework, or today's homework, only accounted for samples of size 2. I could take samples of any size. Samples of size 2, samples of size 3. That would make me a pretty mean person if I did that, because remember, how many samples are there with replacement? There are big N to the power of little n samples. So in this case, there were 5 squared samples, 5 raised to the power of 2, or 25 total samples. So here they are. Here's all 25 samples. And you will also get a copy of this worksheet answer, or this answer worksheet, I'm sorry. Most importantly, after you take those samples, which by the way, to collect those samples, 6 points on the next test, if you can collect all these samples. Then you take the sample means. Please don't make a mistake and go too quickly calculating sample means. The average of 2 and 2 is 2. The mean of 2 and 5 is 3.5, and so on and so forth. Then take the sum of these sample means, and the sum of those sample means is 150. There are 25 total samples, so you take 150, you divide it by 25 total samples, and you get the mean of the sampling distribution, mu sub x bar, is 6. Now let's find the standard error. Remember from the lesson, this is called the standard error, aka the standard deviation of this sampling distribution right here. Standard deviation of this sampling distribution of all this stuff. That's the sampling distribution. All right, so I find all my x bar squares and I sum them up. They turn out to be, or the sum turns out to be 985. I divide by the 25 samples minus the mean squared. So minus 6 squared, which is 36. I put all that together and I get a standard error of 1.844. Notice how that compares to the standard deviation of the population as a whole. Standard deviation of the population was 2.61. The standard error of the sampling distribution was only 1.844, a smaller spread. I wonder why. All right, foreshadowing to my end of homework question to you. All right, so that's number 1, done. 6 points if you can do part C on the test. By the way, on test number 3, question number 1 will be sampling with replacement, just like this. If you can do these 3 things, list the samples, 6 points. Find the mean of the sampling distribution, 6 points. Find the standard error, 6 points. There's 18 points right there. Let's go to number 2. Same exact thing. A and B, same situation. Okay. Now, if you're sampling without replacement, there are big N, C, little n samples without replacement, or in this case, 5C2 or 10 samples. There are the 10 samples right there. Notice I have no 2,2 or 5,5 or 6,6 or 7,7 or 10,10, but I also don't have 5,2. Why? Because I already have 2,5. You do not have to write those repeated samples. All right. Okay, so I found my x bars, summed them up, and got the sum of the x bars are 60. I divided by the 10 samples, and I got a mean of 6. This is too coincidental. Timeout. The mean of the population, 6. The mean of the sampling distribution with replacement, 6. And now the mean of the sampling distribution without replacement, 6. There has to be a connection here. There is. We will get to it in our next lecture. The standard deviation, 2.61, same as above. Standard error, I take my x bar squares. I sum up my x bar squares and I get 385.5. Hopefully you got that as well. I plug it into my formula. I take 385.5, divide it by the 10 samples, and subtract the mean squared. Don't forget to take the square root of the whole thing. And my standard error here is 1.597. And that's it. That's the homework. Again, you will get 6 points. On question number 2, if you can find the mean of the sampling distribution, you will receive 6 points. On question number 2 of test number 3, if you can find the standard error, and you'll receive 6 points if you can create these 10 samples. Just for doing all that. 18 points right there. Now my final question before I leave you, why are the standard errors all smaller than the standard deviation of the population as a whole? Normally, this is the time in class where I would pause and let you come up with a solution. Here's the real answer. All right, when you have a population at large, you might have raw scores that are very spread out, and the standard deviation is one big value. However, when you take a sampling distribution, the whole point of a sampling distribution is to average the numbers from the population. And what happens if you average a really low score with a really large score? That's right, you get numbers that are more tightly packed, averages. Okay, and when I take the standard deviation of those averages, aka the standard error, that spread is going to be lower and therefore more predictable. The whole goal of a statistician and that statistician collects data is to get predictable, reliable results. And the way to do that is to collect many samples, to take the mean of those many samples, and to take the standard deviation, aka the standard error, from those samples. And that, my friends, is the end of this homework. Thank you very much. We'll see you again.